Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're getting back on the Diresta Bandsaw project, which has been, quite honestly, kind of on a hiatus here for a while. And I've explained this in the past, but I think a lot of people don't remember or don't know, but I was needing my horizontal boring mill to be able to do some work for the Diresta Bandsaw project, and the boring mill wasn't finished. So I kind of swapped gears about a year ago from focusing on the bandsaw project to getting the boring mill project finished up. And it took me about a year to do that. There was a lot of work in rebuilding that machine to get it back up and going, but it is up and going again now, or should be. I haven't actually used it for a job yet. We got one coming up on the Diresta Bandsaw project. But I am happy that now that we've got that more or less finished, maybe not finished, but at least usable, we can get back onto the bandsaw project. And that is what we're going to be doing today, is getting back on that. And for that, I need to make a new shaft. This shaft right here, this is the shaft that drives or that mounts onto the upper bandsaw wheel. We've already remade the shaft on the bottom. This is the original one. It is extremely worn. I'll zoom in here in a minute and show it to you, but we're going to be making it a nice new shaft. I got a piece of steel here that we're going to be making a new shaft out of. Now, this is a little bit of a challenging project, and just like the bottom shaft, the hubs on the bandsaw are tapered. They have a taper in them so that when you tighten them up, that taper tightens up, just like a Morse taper tightens up in a drill press to put a drill chuck in. So we got a taper that's got to be machined and matched. We're going to do that over on the lathe using the taper attachment. We're going to use the original taper to set it up on the taper attachment, and then we'll come and cut that taper. So without further ado, let's get it going on this project. Again, I want to show you the shaft we're starting with, and then we're going to get over here and get started making a new one. So this is the original shaft on here. There was a collar on this end, and of course a nut that tightens up on the bottom that goes up against that bandsaw hub that tightens that in place. Now, the original shaft, it measured 1 15/16, so 1.9375 was the original diameter, and you can see on both ends that it drops down, and you got a lot of irregularities in here. It is all kinds of different measurements in here, and basically what happened is this machine runs on Babbitt bearings, and the Babbitt bearings just wore down over the years, and it actually got into the metal on the hub and started wearing this down. And probably some of this was just from the Babbitt bearings themselves. But, you know, that's about 30 thousandths undersized. You get down here and it's almost 100 thousandths. Yeah, that's about 100 thousandths below size down here. So, you know, it'd be nice if we could reuse this shaft, but by the time I weld all this thing up and turn it back down, I probably would have introduced so much heat that the hub wouldn't be running on true anymore and have a little bit of wobble in the wheels. I think it's just better just to go ahead and make a new shaft altogether. This is some 2-inch diameter stuff up here, so we got a little bit of material that we can take off of that to get down to, well, 1/16 of an inch. It's got to come off this total diameter to get it down the size. And of course, we got to turn the taper down here on the bottom. Set up over here in the lathe, I have my steady rest supporting this out here on the end. It's so long to give me some support, and my goal is I'll put a center in the end down here, and that will ultimately support this. But until then, I've got the steady rest holding it in place. So right now, what I want to do is go ahead and just kind of face this front here, put a center in, and we're going to turn down this diameter here to a little bit above whatever that diameter is for the thread, and then from there we will flip it over, face the other side, and put a center in it, and then we'll be ready to start actually doing our turning on the main diameter. So let's get at it here. got a mark on here where I want to turn this down. This is actually, again, longer than what that threaded area is going to be, but that just gives me a little bit more room to grip onto. I purposely cut it a little bit long. I've got my live center in here supporting it on the end. I decided, since I already had the steady rest in place, that we would just continue to use it. That'll help keep any chatter out of this, keeping any vibrations and stuff out. So we're going to go ahead and get this turned down. The threaded area is 1.25 inches. I'm probably going to turn this 1.5 inches, and we're starting at 2 inches. So I got basically a 1/2 inch to take off of this. So let's come in here and touch off. It'll take about 100 thousandths pass if it'll take it. And it looks like it's turning good. Nothing critical on any of these dimensions or measurements right now. Right now it's just kind of prepping it to do the more critical work here in a little bit. So we'll just go ahead and turn it down to that line and stop, and then, like I said, we're going to turn it down to roughly 1.5 inches. It doesn't have to be exact. When we get down here to this bottom, I'm going to go ahead and face out so that I have a square shoulder. And we've got our end pretty well done. I'm going to relieve those corners. Just break the corners with a chamfer bit here. And actually, I'm going to put this cutter back in. I actually want to just clean this up here just enough to get a surface that I can indicate on when I chuck this up, because I'm going to do it in the 4-jaw chuck. So I just need a diameter that I can put an indicator on and make sure everything's running true. We'll check that out here in just a minute. I may need to take just a little bit more. Yeah, that's barely getting below that rust layer right there. I'm just going to take about 5 thou more. Just fuzz it across there. I think that'll clean it up. I've got my 4-jaw chuck in on this side. We've got it supported by the steady rest on the other side right now. And what I want to do is get this dialed in. And I just put this in the chuck and just kind of looking at where these jaws were. This is kind of where I'm at, and I'm within about 15 thou right off the bat, which is good. So when you look at this, you see the needle going. And when the needle's coming towards me, the part is coming towards me as well. I can tell by just looking there. So, you know, that's my high right there. It needs to go in the other direction. So what I'm going to do is I'm going to come around here. I'm going to mark 0 on this side. I'm going to loosen this one up just a touch. Doesn't mean much. We're going to come back around over here. And what I want to do is I need to move it half of that distance, whatever it is, to 0. So we're just going to roughly come in here. I'm just going to snug this other side up for now. And then we're going to do this process again. We're going to find that's our low right there. So I'm going to loosen it up, come around over here. We'll take about half of that. All right, there's my low. Go 180 degrees. Needs to be about where it's at. I'm within a thou right now. We got it running within 1,000, so I'm happy with that. Okay, let's go ahead and face the end and put my center in the other end. All right, here we go. Just come in and touch off on that. This side looks like it had been faced before, but there is no center in it. Here we go. And we are supported. I'm going to go ahead and take out this steady rest now. We're pretty much done with it for the time being. We're going to be turning this entire shaft, so this is going to be in the way. So we'll just get it out of here. I should be able to just lay this thing down. And bring it right out from underneath the bottom. And we're going to come in here and touch off on this. I got to take a 1/16 of an inch, which is a 62.5 thousandths, so not a whole lot to take off of this. Because of the length, I don't want to really go hogging on it too much. I'm going to take my time, probably do about 20 thousandths at a time, and get that turned down to the diameter we're looking for. So, yeah, I'm just going to feed in about 20 thou and let her go across there. Because of the length of this, it's going to take a little time. I'm not going to make you guys watch it all, but we're just turning metal off. Again, I am purposely taking light cuts here because I know from experience on a long shaft like this, you're going to get a little vibration in it, particularly when you get out in the center. That can affect your surface finish and everything else. So just take your time, get it knocked out. We don't have a whole lot of metal to take off of this. All right, guys, this should be our final diameter. We're just going to finish turning this out, and we should have it set. Once we get that done, we'll be ready to set our taper up and get that turned, which is going to be a little bit of a step involved in that. But this, like I said, should have our outside diameter of the shaft all finished up. And with that, we're done. We're going to pull this shaft out. I'm going to get the other shaft running between centers, and we're going to use the original taper to set up our taper, and then we'll put this shaft back in and actually turn that taper. So what I've done is I've gone and I've taken the original shaft that came off of this. Of course, from here up is pretty much all chost, but this taper that fits up in the hub of that bandsaw wheel, this is still a pretty good surface. It's really not a wear surface. It's pretty much the way it was when they put that bandsaw together 100 years ago. So I'm wanting to replicate this taper. And since I've got that taper to work with, we're going to actually set the taper attachment up on here so that it's going to automatically work the way we want to. So right now, I've got my indicator just set up on the saddle here. I'll want to put it onto the actual cross slide once we start testing it, but just to kind of show you what's going on. Right now, it's on 0. As I move down, you're going to see that dial is going to be dropping off. That's indicating that we've got a taper in here. If this was straight, like we just turned up on the top, when we move down, it should stay on 0 pretty much the whole way, but we've got a taper here. So what we're going to do is we'll go over here and start adjusting the taper attachment, the taper on the taper attachment, and we'll run the indicator back and forth on this. And basically what I want it to read is I want it to read 0, because what's going to happen is as the saddle moves across, it's going to actually be moving the cross slide in at a rate that will match this taper. So once it's set up, it should read pretty much 0 from one side to the other. That's the game plan. It's going to be a lot of trial and error, but we'll get it done. So I'll bring you back here in a minute once I kind of get the taper attachment ready to start setting up. So we're going to start working on this taper attachment, getting it set up. And basically the way a taper attachment works is that we're going to tighten up a bolt over here on the back. They got a bar that comes off of this piece right here. This is the actual, we set the taper, this bar. And whatever taper we set that to, as the saddle moves, this is going to stay stationary. I'm actually going to tighten this down so that it does not move. And as you move the saddle back and forth, we're going to tighten the cross slide up. And in fact, that's the first thing I'm going to do. There's a bolt right here. I'm going to tighten this up. And when I do, it's basically going to deactivate the hand wheel on the front of the cross slide that you use to manually move it in and out. Once this gets tightened up, what's going to control the movement on the cross slide is in relation to this taper. So again, let me go ahead and tighten this up, and you can kind of see I'm going to tighten up the bracket that fixes the taper bar and holds it in place. So now, again, what's going to happen, I'm going to go around the other side, and you're going to see that when I move this back and forth, this bar is going to stay stationary, and there's a piece that rides on this, and it's going to move the cross slide in relationship to this bar. All right, here we go. So see how that's staying stationary in the back, and the cross slide again is tied directly into that, and that's how we're going to run our taper here. Okay, with that done, what I'm going to do is I'm going to loosen this taper bar up over here. It pivots in the center, and right now I've got too much of a taper in here, so what I want to do is I actually want to bring it around and flatten that out just a little bit, and I'm going to tighten this up. And now it's just a matter of trial and error. I've got to come over here and just get this thing matching the taper on the other side. There's a bolt on the bottom there that tightens it up on this side. So it's just going back and forth until I get that indicator running 0 and making small adjustments until we do. So I'm going to spend some time working on that, and once I do, I'll bring you back and show you that we got it set up. Got it set pretty darn close here. I'm going to go out. I usually go past my taper. I come back in because there's a little bit of backlash on the taper attachment, just in that screw going back and forth. And I'm going to 0 my indicator right there, and we're going to pull it in. Now, there's a little bit of bouncing going on. That has to do with the rack that drives the carriage here, but I'm just kind of looking, and it's staying right there around 0. Like I said, there's a little bit of about a thou of just interference from that rack. There's nothing I can do about that, but it's pretty much dead nuts on where we want it to be at. I think we are ready to run that taper. So again, when we are following that taper attachment and we're coming across here, it's reading 0 because it's running. It's going to be this, as the saddle moves in, the carriage is going to be moving in at just the right rate to match the taper. So now we can take the sample piece out, put our other piece back in again, and hopefully turn that taper. And let's get on that. So I've got my shaft back over here, and we're getting ready to turn the spindle. I have got it set up between centers. As you can see here, we have the taper attachment set to match that taper. Should get us pretty darn close. A couple little comments here. When turning between centers, particularly on a taper like this, it's important to make sure that you're dead center and your live center, the two centers on the end line up with one another. I went through this machine a couple of years ago, and I've pretty much got my alignment dead nuts on. So I did check that off camera, just ran them up together, and they match up perfectly. And you also want to make sure your cutter is set as close to the center that you possibly can, not be above or below. That's going to help you make sure that you're turning a good taper based on what we're doing. Because we actually measured off of the original shaft, it should get us really, really close. I'm not actually mathematically calculating here. We're just duplicating the taper that we were provided, which is my preferred way of setting up a taper. In fact, many times I'll actually, if I know I need a specific taper, I will grind a taper that I can put up on here and actually indicate in rather than trying to dial it in mathematically. I just personally get better results there. So I think we are ready to go here. We'll fire the lathe up and start turning that taper. All right, I'm gonna pull my cutter out, and as you can, I don't know if you can see it or not, I can see it, but as it's coming out, it's actually moving away from the part. I like to go way past the area that I'm cutting and then come back in, because there is a little bit of backlash just whenever you're going from one way to the other. It's just from the wearing the nut and anything else that you got in here. So to make sure your taper's running good, I like to, let it run up an inch or two farther than what it needs to make sure that I'm running on that taper up there and everything's going good. So we're going to go ahead and fire up the lathe. Before I do that, let me just comment here. Because I can't control my cross slide because of the way it's tied into the taper attachment, I actually have to do my feeding on the compound. Now I could turn it back to 90 degrees and read it directly, but I've left it at the angle here. I can compensate for it. It's a little bit easier if you get it at 90 degrees, but you will do your feeding in on the compound rather than on the cross slide doing an operation like this. I'm going to take about a 10 thousandths cut. We're going to come in here and I'm just going to engage my spindle down here. And what will happen is it's going to come into contact somewhere along in here and it will finish cutting out. You see it's starting to make contact right there. And as we go, it's making a deeper and deeper cut. All right, we are through. Again, so I don't drag my part, I'm going to actually look and see where I'm at on my compound. I'm reading at 120 right now. I'm going to back that off, pull out here, go past where I'm going to start, come back in. I'm going to go back to my 120 measurement, and we'll just feed in a little bit more. I'm going to do about a 15 thousandths pass on this one, and it's going to engage up a little bit farther than it did before. And again, just cut that taper on out. So looks like we're about to start right there making contact. And as we go, that cut's going to get deeper and deeper and deeper. All right, I'm reading 10 on my compound, so again, I'm going to back it out. We'll go out past it, come back in, get our backlash out. I'm going to go back to my 10 measurement, and we're going to feed in a little bit more. All right, I am going to stop right here. I should have a good bit more metal to take off of this, but I want to just kind of see where I'm at. And I'm just going to get a measurement here. We are at 1 inch 900 thousandths. We're going to 1 inch 845. So I've got about 40, really about 40 more thousandths I need to take off on the small diameter down here to get to where we're at. So, and I've been taking about a 10 thousandths on the compound, but because again we're at an angle, that's on the hypotenuse, it won't be actually 10 thousandths. I'm going to see how much 10 thousandths is actually cutting. I'm just going to experiment here. So let me get a really good measurement. I'm going to call that 900. So, and I'm on 20 on the compound. I'm going to dial out. Again, come out, go back in. I can feel it getting tight. And I'm going to go to 30, which is 10 thousandths deeper on the cross slide. We'll engage our spindle here, or engage the carriage, and I'm going to measure and see how much we actually took off. Do another measurement here. That's just going to help me kind of figure out how much I need to do. I'm going to take another 10 thou. All right, I'm right where I want to be at on my depth, I think. So I think what we're going to do is we're just going to back off here. I'm going to pull that out of the way, and I am going to take some emery and just kind of polish this to make sure we got a nice surface on there. This is the tapered hub that this is going to fit up into. This is the bandsaw wheel. Here's the original shaft. Of course, the taper is all original, you know, really probably hasn't been taken apart since this machine was put together. This is worn down here, but that's an original finish. But as that goes in, as you push it in, you can just feel it. It's just, I mean, that shaft is in there tight. In fact, I just about got to have something to bump it out. Let me just kind of test the fit here with the new shaft. Let's see what happens. Oh yeah, it's done the exact same thing. It's not, the shoulder's not all the way on the other side, which is what, there's a nut that's going to pull that tight, so it feels like a good fit. I can see some contact in there all the way around just from the rust. I'm going to see if I can take a little bit of spot and dye and put in there and actually blue it up and see what it looks like. Here's some blue. This is a water-soluble bluing that I use with my metal scraping. Just some Canode blue. This is not the Prussian blue, which stains so bad. This is actually water-soluble. But I'm just going to put a little layer all up in there. I'm not pushing it in super tight. I want to actually spin it in there. And you can see, it's interesting, it's making good contact up here, and it's making contact at the back. There's a little bit of a gap in there, although there is some blue in there. I mean, it's making pretty, it's not as bad as I thought it was going to be. So, all right, that kind of shows me where I'm at. I kind of want to compare that to the original shaft. Very similar. It's making contact in the back part, but not so much up here. So at least our tapers match. You know, I'm getting kind of a combination of oil and blue coming in contact with the shaft, but it's interesting to me that you can see on the original shaft, I mean, it's making contact all up through here, but it's making pretty heavy contact in the top, light contact down here. This is the new shaft, and we're actually making fairly heavy contact a good bit farther down and still light contact down in the bottom. The one I made actually looks like it might fit a little bit better than the original, but they're pretty close to one another. What can we do to improve this fit? I mean, I can sit here and put some lapping compound in there and really lap these two shafts together. Honestly, I mean, just looking at the contact between the two, I think that the new shaft is going to be plenty fine like it is, but I'm going to probably do a little lapping just to be on the safe side. It won't hurt anything. More contact is better, so you know, we're going to do that. Because of the size of the wheel over there, I don't really have a way to mount it into a machine where I can really power lap this. So it's going to be literally hand lapping, which is going to be slow, but I'm going to take a little bit of time and just see if I can improve that a little bit, and we'll go from there. So this is the lapping compound I'm going to use. It's called Time Saver. This stuff's been around for a really long time. My understanding is they kind of invented this stuff during World War II. The U.S. Navy did. They were needing to lap in a lot of parts on big ships they were building, and because of the time crunch and getting ships out in a timely fashion, they wanted an abrasive that they could use as lapping compound, that if it didn't get completely cleaned out, so in other words, material got left in a piece of machinery, that the abrasive would break down rather than continue to cut over a long period of time. So if you didn't get it cleaned out, like I said, it would break down. It's not going to do major damage, whereas most abrasives are not going to break down and can cause a lot of damage down the road. This is just a little sampler pack that I got. It has both the materials. The yellow bottles are for soft metals. The greens are for harder metals. And when I think of soft metals, I'm thinking aluminum, brass, bronze. Whereas this is going to be more steel. So we're going to use the green one, and I'm just going to use a coarse, a 55N. Let's see, this is the 55 coarse right here. That's what we're going to use. And when you open this up, it's just a powder. And what I'm going to do is I'm going to take a little cup here. I'm going to put some of this in here. You put this with some oil and create a slurry, and you put that, brush that on, and then you just start lapping it in. So let me go get a brush and we'll start doing this. I'm just going to take a little bit. Doesn't need a whole bunch here. I'm just going to use a little bit of light spindle oil here. And again, we'll kind of make a slurry. All right, and then I'm going to brush this onto the hub itself. We'll just apply some of this onto the shaft. And here we go. We're just going to put this in there. And you can hear it kind of crunchy. It's like having sandpaper on it. And it's just going to take multiple times of doing that. We'll do that, and you can kind of hear it when it quits cutting, and you pull it out, put some more compound on it, repeat the process, and if you want to, you go to finer grits as you go and get a smoother finish. But nothing fun about this. We'll bring you back in a bit. So here's the old shaft, here's the new shaft. The encouraging news is that, again, I think I'm getting better contact on the new shaft than I am the old shaft. One thing that's interesting is these little rings in here. I've been noticing that. I've actually done this a couple of times off camera. I've been noticing that each time, and it's getting better as I continue lapping. But I think what's going on is inside that bore over there, there was a little bit of irregularities in that bore where there was some little grooves almost in there. You can't even feel it with your finger, but it shows up here in the blue. And I think when they bored that hub, that every so often it had something in the lathe and it was just kind of making a little ring, because we're getting it on both, getting that pattern on both of these pieces. But like I said, the encouraging news to me is that I know that this taper here lasted over 100 years on that bandsaw. We got better coverage on the new one than we do on the old one. So I think we're good. And yeah, I could continue lapping until I got perfectly blue contact from one end to the other, and got those ridges in the hub kind of worked out, but I just don't think it's worth it. I just don't think it's necessary. I think we've got well over 85% coverage in there, and 100% coverage is probably not realistic. So, I think we're good. So we're going to call it quits there. Well, guys, I think we're about to a stopping point for today. On this shaft, I still need to turn the threads down here on the end, but I'm purposely holding off on that. I'm going to use this shaft as a mandrel to pour the Babbitt bearings for it, and I just want to leave that on there until I get completely through with that. Then we'll bring it back over to the lathe, and I will shorten this length and cut those threads on there like we need to, and then I think it'll be all ready to go back together. But I want to get the bearings poured first, so that's going to be coming up in a video here pretty soon. We're going to be making some positioning rings to go on here to position this shaft properly in that casting that it fits up into, so that we can pour the Babbitt. And once that's done, like I said, we'll come back and finish this shaft up. But we are making progress towards getting this top wheel shaft, a new one fabricated or machined and ready to go. So, and I'm real happy with how this one turned out. So guys, with that, we're going to sign off. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated, and they both help feed the algorithms over here on YouTube so that my channel can get discovered by other people, making it more popular. We really, really appreciate your input when you do that. And again, as always, thank you so much to all the guys who support the channel through Patreon, PayPal, etc. I've said it a million times, and I cannot mean it enough. We really could not bring all the content, take the time to shoot video, and bring this stuff to you if it wasn't for a lot of those contributions that are coming in. So the guys that do that, greatly appreciate it. If you can do it, we'd love for you to do it. If you can't, nah, it's not the end of the world. But for those that can and do, thank you, thank you, thank you. I really do appreciate it. And with that, that's a wrap. We'll catch you on the next video. Again, thanks for watching.